In the previous class, we have seen time response for second order underdamped system. Now we will see the time domain specifications for second order underdamped system. Here we are having the response for second order underdamped system. The first time domain specification is raise time, TR. TR means the time taken to reach first time final value. That is TR. So it reaches first time final value at this point. At this point. Therefore, time taken to reach this point is TR. But by definition, it takes time from 10% to 90% also, we can say like that. But while calculating, we will take from t equal to 0 to time taken to reach 100%. TP is, this is overshoot. It goes beyond the final value and then return back and oscillates. So this part, this is overshoot. This part is, follow my point, this part is overshoot. Time taken to reach this maximum value is called TP, peak time. This is peak time. This time is TP. The time at which the maximum value is reached, that is called TP. The magnitude above final value is called peak overshoot. And TS is settling time. TS is settling time, time taken to reach 98 to 102% of final steady state value and remains there. Already I told you that tolerance is required. The tolerance is 2% means from 98% to 102%. If it is within that oscillation, but the tolerance with the 2% oscillation means we are assuming that it is settled. So at this point, it reaches within the 2% tolerance. Therefore, the time taken to reach this point is TS. So up to this point, it is called transient response. After this, it is called steady state response. So we have seen peak time, maximum overshoot MP, and then settling time also we have seen. Decay ratio. Decay ratio means the first peak is the magnitude above final value is A. The second peak, the magnitude above steady state value is B. That B by A is called decay ratio. The ratio at the speed at which it decreases. We are telling in terms of decay ratio, B by A. That's all. These are all time domain specifications. We'll derive the expression for each expression. First, let us derive time domain specification of raise time, TR. What is the definition for TR? Time taken to reach first time final steady state value. What is the magnitude at that point? CT equal to 1. What is the expression for response? Second order response for step input, second order underdamped system. Zeta is less than 1. For that, what is the response? Already we derived C of t equal to 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dt plus 5. For zeta less than 1. Here, when it reaches first time, when it reaches first time steady state value, that is final steady state value, this is TR. TR, first time when it reaches, the magnitude is 1. Therefore, we can substitute C of t equal to 1. If you substitute C of t equal to 1, these two ones are getting cancelled. Therefore, this part is equal to 0. That is e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dt plus phi equal to 0. Why this is equal to 0? Because at this point, the value of c of t equal to 1. If you substitute that, 1 getting cancelled, therefore this part is equal to 0. But at what time this value we entered? A t equal to tr. That's why wherever you find t, it becomes tr. E power minus zeta omega n tr upon square root of 1 minus zeta square sine omega dtr plus phi equal to 0. That we got. This is the magnitude of sine signal. Am I correct or not? Suppose I'm having a sine signal whose magnitude is 5 means, whose magnitude is 5 means, this is its magnitude is 5. How we will write 5 sine omega t? We'll write like this. This 5 indicates that the magnitude, amplitude of this signal. Therefore, here sine omega dtr plus phi, for that the magnitude is e power sine zeta omega n tr upon square root of 1 minus zeta square. The sine signal always oscillates. Even at infinity, it oscillates. Even at infinity, it oscillates. It never becomes rest. Sine signal always oscillates. Sinusoidal signal will become 0 at some interval. Sinusoidal signal becomes 0 at some interval. At this point, it becomes 0. At this point, it becomes 0. At this point, it becomes 0. So, but this is not equal to 0. At this instant, this is not equal to 0. Am I correct or not? At this instant, the magnitude is not equal to 0. The magnitude is not equal to 0. Therefore, this is not equal to 0 and this is equal to 0. Why? This periodically it becomes 0. At this point, this becomes 0. That's why the right hand side becomes 0. Therefore, sine omega d tr plus phi equal to 0. At this moment, the sine wave equal to 0. That's why right hand side we got 0, because this is not equal to 0. The magnitude is not equal to 0. The sinusoidal signal, periodically it becomes 0. At this instant, this becomes 0. Therefore, sine omega d tr plus phi equal to 0. And this is not equal to 0. The magnitude is not equal to 0. Therefore, sine omega d tr plus phi equal to 0. Sine theta equal to 0 means theta equal to 0 or n pi, we can say theta equal to n pi, 0 or n pi. So here it is not 0 because after some time, that's why it must be equal to n pi. Omega d tr plus phi equal to n pi. At every instant, this is n equal to 1. At this instant becomes 0. Here n equal to 2, it becomes 0. Again n equal to 3, it becomes 0. At n equal to 4, it becomes 0. Like that. So at n pi, this omega dtr equal to n pi. That's why it becomes 0. Or this tr is first time it reaches 0. First time it reaches 0. Therefore, n equal to 1. We can write, therefore, we can write omega dtr plus phi equal to pi. Why? At when n equal to 1, it becomes 0. Or tr equal to omega dtr plus phi equal to pi. Therefore, we can write tr equal to pi minus phi divided by omega d. But omega d equal to what? Omega n multiplied by square root of 1 minus zeta square. Therefore, tr equal to pi minus phi upon omega n square root of 1 minus zeta square. Square root of 1 minus zeta square. Square root of 1 minus zeta square. That's all. Therefore, the expression for tr, time at which it reaches first time peak, is pi minus phi upon omega n square root of 1 minus zeta square. this phi equal to tan inverse of square root of 1 minus zeta square upon zeta in radians. Its unit is in radians. Peak time. Peak time. Rise time we have seen. Now let us see peak time. Peak time is what? The waveform it goes over first overshoot and second overshoot, third overshoot, like that it goes. Peak time means first the maximum amplitude occurs, that is TP, peak time. We have to find this TP. To find a peak, what is the slope at this point? What is the slope at TP? Slope at TP is, what is slope at TP? Slope means what? Tangent. Slope means tangent at that point. If you draw a tangent at this point, it will be a horizontal line. Am I correct or not? If you draw a tangent at this point, it will be a horizontal line. What is the slope of that horizontal line? 0. Slope of that horizontal line is 0. Therefore, slope at TP equal to 0. Simply we can say that slope at TP equal to 0. How to find the slope at TP? What we have to do is, we know the expression for C of t equal to 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square multiplied by sine omega dt plus phi. This is the expression for C of t. How to find the slope at TP? Replace, differentiate this. If you want to find the slope at any point, we have to differentiate this and equate to 0. Why we are equating to 0? Tangent equal to 0. When the waveform turns, it means what? Either it will be at maximum or at minimum. Both are possible. That's why in mathematics, if you equate to 0, you will get either maximum or minimum. To find whether it is maximum or minimum, we will find the second derivative, it must be negative. Derivative of derivative will find if it is negative, then it is maximum. If you see the second derivative at this point, you will get negative slope. At this point, you will get positive slope, because after that it will increase. After that it will increase. That's why you will get positive slope. Here, after that it will decrease. That's why you will get negative slope. That's why second derivative becomes negative at this point. Okay. But we know that here we'll get a positive value. That's why we are not finding the second derivative. We'll find the first derivative of this equation. What is the first derivative of this equation? C of t equal to 1 minus. If you differentiate 1, what you will get? 0. That's why it is not mentioned here. 0 minus, what is that? E power minus zeta omega nt upon square root of 1 minus zeta square. We wrote as such. We wrote that as such. Then if you differentiate sine omega dt plus phi, what you will get? Cos omega dt plus phi. If you differentiate this omega dtp, you will get omega d. That's why we wrote here. So product function, derivative of AB. So we differentiate cos omega dtp plus phi. We got differentiation of sine omega dtp multiplied by omega d minus. Now we have to keep this as such. Sine omega dt plus tp, sine omega dtp plus phi, we are keeping as such, and differentiating this part, e power minus zeta omega and tp. We differentiate that. What is the coefficient of tp? Minus zeta omega n upon square root of 1 minus zeta square. If you differentiate exponential function, you'll get the same. That's why we are writing e power minus zeta omega n tp. That's all. Why t is replaced by tp? We are finding differentiation at t equal to tp. That's why all t is replaced by tp. At that point, what is the slope? Slope is 0. That's why equated to 0. Now, common terms will be taken out. E power minus zeta omega and t in both terms are there. That's why we are taking that outside. We are taking that e power minus zeta omega and tp outside. This Square root of 1 minus zeta square also in both terms, that is also taken outside. Here, cos, this is minus, that's why we are putting minus sign here. Cos omega d tp plus phi multiplied by omega d. Multiplied omega d equal to what? Omega d equal to omega n square root of 1 minus zeta square. So instead of omega d, we can write omega n square root of 1 minus zeta square plus sine omega d tp plus phi multiplied by zeta omega n. This minus sign becomes plus. This becomes plus. Okay. Okay. This becomes plus because of 2 minus sign, it becomes from sine omega d tp plus phi zeta omega n equal to 0. Again, at this point, the magnitude is not equal to 0. The magnitude is not equal to 0, and this can be, this omega n also can be taken outside. In both terms, we have omega n. That's why omega n also can be taken outside. The omega n also can be taken outside. So what you will get? This is negative, this is positive. That's why you will write this first zeta sine omega d tp plus phi minus square root of 1 minus zeta square cos omega d tp plus phi. But this is not equal to 0. The magnitude is not equal to 0. But sine term, periodically it becomes 0. At this instant, this periodical function is 0. Therefore, we can write zeta sine omega d tp plus phi minus square root of 1 minus zeta square cos omega d tp plus phi equal to 0. This periodical function is equal to 0. If we equate this equal to 0, we can substitute zeta equal to what? Already we have one expression. This is phi. This is equal to square root of 1 minus zeta square, and this is zeta, and this is equal to 1. Therefore, zeta can be written as cos phi. Zeta can be written as square root of 1 minus zeta square can be written as sine phi. If you substitute this here, this zeta becomes cos phi, and the square root of 1 minus zeta square becomes sine phi equal to 0. So this is what? Sine A cos B plus cos A sine B. Therefore, sine A plus B. Sorry, minus sign is here. Therefore, sine A minus B. Here B is phi. Therefore, A is omega d tp plus phi minus phi. Phi getting cancelled. Therefore, sine omega d tp equal to 0. Sine omega d tp equal to 0. But that means omega d tp equal to either 0 or 1 pi or 2 pi, etc. This is happening at the first time. Therefore, we can equate this equal to pi as we have seen in the previous derivation. Omega d tp equal to pi. Therefore, tp equal to pi upon omega d. Or we can say that pi upon omega d can be written as omega n square root of 1 minus zeta square. Tp equal to pi upon omega n square root of 1 minus zeta square. Time taken to reach the peak value is pi upon omega n square root of 1 minus zeta square. This is second derivation. These are all useful to solve sums. That's why you have to memorize all these derivations. The formula has to be remembered. TR equal to what? Pi minus pi upon omega d. Here, TP equal to what? Pi by omega d. So you can easily remember. TP equal to what? Pi minus pi upon omega d. Maximum offshoot, MP. This is the waveform we got. This is MP. This magnitude is MP. It occurs at what point? TP. Therefore, Ct equal to C of t equal to MP, C of 1 minus C of t equal to MP. T equal to Tp. At t equal to Tp, it is MP. At this point, what is the time? Time is Tp. If you substitute t equal to Tp and subtract from 1 because its magnitude is 1, which is bigger? C of t, because it is overshoot. That's why C of t is bigger. That's why we'll write C of Tp minus 1 equal to M. C of Tp minus 1 equal to M. What is C of Tp? We know that C of t equal to 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dt plus phi. So here, wherever you find t, substitute Tp and replace C of Tp by this. So what you will get? What you will get? C of Tp is replaced by this 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dtp, because at this point we are finding Tp plus phi minus 1, because we are subtracting minus 1, equal to MP. This is MP. 1 getting cancelled. 1 getting cancelled. 1 getting cancelled. So we are having e power minus zeta omega n Tp upon square root of 1 minus zeta square sine omega d Tp plus phi. This we have to find. But we know the value of Tp. We can substitute the value of Tp. If you substitute here the value of Tp, what you will get? E power minus zeta omega n Tp equal to pi by omega d, that is omega n square root of 1 minus zeta square. I am substituting Tp upon square root of 1 minus zeta square sine omega t. Tp equal to what? Pi by omega t plus phi equal to MP. The minus sign is there still. So omega d getting cancelled here. Here omega n getting cancelled. Omega n getting cancelled. So we can write sine pi plus phi is there. Sine pi plus phi. This can be written as MP equal to e power minus zeta omega n pi by omega d. Omega n getting cancelled. MP equal to omega n getting cancelled. E power minus zeta pi upon square root of 1 minus zeta square upon 1 minus zeta square. This sine omega d, here also omega d getting cancelled. That's why we can write sine pi plus phi. That can be written as sine a plus b. Sine a cos b plus cos a sine b. Sine pi equal to 0. Therefore, this term becomes 0. Cos pi equal to minus 1. Cos pi equal to minus 1. Therefore, this minus sign is getting cancelled now and it becomes positive. So, MP equal to e power minus zeta pi upon square root of 1 minus zeta square, and sine pi equal to what? This sine pi equal to square root of 1 minus zeta square. Already we derived. If you substitute that, the denominators square root of 1 minus zeta square and sine pi getting cancelled, because sine pi equal to square root of 1 minus zeta square. Therefore, MP equal to e power minus zeta pi square root of 1 minus zeta square. MP equal to e power minus zeta pi upon square root of 1 minus zeta square. If you want, it will be a factor. Here, this is 1 means this will be about 0.6 or 0.4 like that. It will be a factor. If you want to represent them, what 0.6 is, what is the percentage of 1? 60%. So to represent in percentage MP equal to 100 times e power minus zeta pi upon square root of 1 minus zeta square. Sometimes it will be asked in percentage. That's why we have to multiply this by percentage. That's all. That's all. So MP equal to this MP equal to e power minus zeta pi upon square root of 1 minus zeta square, or percentage MP equal to 100 times e power zeta pi upon square root of 1 minus zeta square. Settling time. From this point onwards, it is within the tolerance of 2%. Morning we have seen that what is tolerance. Noise is inevitable. That's why always it will oscillate around the final value. That's why 2% is taken as tolerance. So after this, it oscillates, but the maximum oscillation is only within that plus or minus 2%. So after this, it is steady state. Before this, it is transient. Now we have to find the time Ts we have to find. Settling time. This point is called settling time. This point is called settling time. We have to find the Ts. Here, C of t equal to what? We have to understand from C of t. C of t equal to 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dt plus 5. This is the expression for C of t. Here, let us assume that finally it settles at 1. It means what? This part becomes 0. This part becomes 0. This part becomes 0 always. Earlier, what we have seen that at this point, the sinusoidal function is 0. At this point, sinusoidal function is 0. At this point, the sinusoidal function is 0. We are assuming like that. At this omega dt plus phi is 0. At this point, like that here, at this point, omega, like that we have derived. But here, the entire part becomes 0. The entire part becomes 0. Then only it will settle at 1. The entire part is not settled at 1. Instead, it is equal to plus or minus 2% or plus or minus 0.02. 2% is 0.02. So this entire magnitude is equal to 0.02. This sinusoidal function always it oscillates. So it oscillates, but its magnitude is 0.02. Therefore, this part must be equal to 0.02. This part must be equal to 0.02. Then only within that 0.02, less than or equal to 0.02. Therefore, we are taking that part alone and equate to 0.02. To find Ts, we are equating this part. Why? Because the C of t becomes 1 means, because settled at 1, let us assume that no noise is settled means this part must be equal to 0. But we are assuming that it is not settled because of noise. It oscillates around 1. Its amplitude is 2. Therefore, the second part is equal to 0.02 plus or minus 0.02. Therefore, you will get value from plus 0.98 to 1.02 because of this tolerance, plus 0.02 or minus 0.02. So its value. Therefore, this value is equal to 0.02. But the sinusoidal value always not equal to 0. Periodically, it becomes 0, not always 0. That's why its amplitude is decided by this. That's why this part is taken and equate to 0.02. if you bring this square root of 1 minus zeta square to the right hand side, you'll get this. Take ln on both sides. If you take ln, the exponential becomes e minus zeta omega n ts. Why I put ts? Because at settling time, that's why ts, e power minus zeta omega n ts. Right hand side, we have to take ln, logarithmic, natural logarithm. That's why ln of 0.02 square root of 1 minus zeta square. Therefore, ts equal to minus ln of 0.02 square root of 1 minus zeta square upon zeta omega n. The right hand side value for different values of zeta, as zeta varies from 0 to 0.9, above 0 to 0.9, it value varies from 3.91 to 4.74. It value varies from 3.91 to 4.74. It value varies from 3.91 to 4.74. Let us approximate this to 4. Approximate this to 4. Then you will get TS equal to 4 upon the numerator value varies from 3.91 to 4.74. Therefore, 4 upon zeta omega n. Therefore, settling time is 4 upon zeta omega n. Settling time TS equal to approximately equal to 4 upon zeta omega n, because the numerator value varies from 3.91 to 4.74. As zeta varies from above 0 to below 0.9, its value varies from 3.91 to 4.74. So in that case, this can be approximated to 4 upon zeta omega n. If you consider a tolerance of 5%, it means what? Plus or minus 0.055%. If you consider tolerance, the numerator approximate value is 3. Therefore, TS equal to 3 upon zeta omega n. In the examination, they may ask for 5% tolerance means you have to consider this formula. 2% tolerance means you have to consider this formula. This is for 2% tolerance. This is for 5% tolerance. So time taken to reach the settling time, the time taken to reach the settling point, TS equal to 4 upon zeta omega n or 3 upon zeta omega n. That's all. We'll see the examples tomorrow.